Hello everyone, today let's take a look at Quantipus number 51, which is another circular combinatorics question, and it's just going to be a little bit more involved than the last one. It's basically an extension of that. You're hosting a dinner party for 4 married couples, so 8 people around a circular table. In how many ways can the guests be seated such that the men and women alternate and that no one sits beside their spouse? So to solve this, let's just take the men or the women. Let's just say it's the women, and let's seat them around this table. So imagine I take the 4 women like so. How many ways are there to do this? Well, when I take 4 factorial for the permutations, I'm overcounting by a factor of 4 because woman 1 could be here, 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 or here with the same orientation, and it would be overcounted 4 times, so we divide by 4 to give us 3 factorial. So now let's go about seating the men. Basically, we have man number 1. We know that man number 1 cannot go here, and it cannot go here because those are both next to his wife. So man number 1 has 2 options. First of all, let's say here or here. And once we place man 1, you kind of have to notice that everything else is predetermined because man number 4, right, has to go somewhere, and he can't go here or here. So it has one option, and it's here. Now, once we've placed man number 4, man number 3 has 2 options, but he can't go here because his wife's here, so man number 3 has to go here. And then man number 2 is the only one we're missing, and they has to go there. So notice that once you place down the first man, everything else is predetermined. And how many ways are there to place down the first man? Well, for any man, they have 2 options opposite where they're not sitting next to their wife. So that gives us 2 options for each one of these 3 factorial permutations. 3 factorial is 6. 6 times 2 is 12, and that is our final answer.